My name is Stephen Tyson. I'm an operations specialist, technical account manager at AWS, and this session is Get Started with Monitoring and Observability on AWS. Now, has anyone ever had a day where they come into the office, or nowadays probably dial in, and their systems look like this? Systems are down or performing poorly, people are screaming to get systems back online, and you are expected to immediately know what the problem is, why it happened, and provide an exact time as to when systems will be back online. I'm sure you've been in this situation. I know I have, and it never happens in the middle of the day. It's usually as you're walking out of the office or attending an important event. These situations also happen to our protagonist, Jane Doe. Now, tenured IT administrators like Jane, who know their system, know where to look and what to do when this happens. It comes from experience, it comes from understanding, and it comes from a deep technical mindset. And it's our job as IT administrators to protect the systems we're responsible for, which means keeping them in a known, consistent state and monitoring them well. Now, many IT administrators today, like Jane, support an architecture like this, a monolith. So what happens when the company Jane works for say they want to move from this, a monolith, to this, a microservices model? Now, Jane's company is moving to microservices, and that's due to the many benefits they bring. They have smaller blast radiuses for changes, they have faster release cycles, there are less constraints with resources like CPU and memory, and they can scale on demand. But any caring IT administrator will immediately have concerns. What happens if Jane has an incident in this environment and needs to resolve an issue? There is so much to monitor. Monoliths have servers as their compute, but microservices have containers, functions, and all sorts of other services. Jane won't be able to access anything via RDP and SSH. Things are created and deleted every minute or even every second, and people are using multiple services and multiple development languages in those services. So the question is, will the way Jane has performed monitoring with a monolith work in a microservices model? And the answer is going to be no. There will be new tools, new processes, and new metrics. And to make matters worse, companies don't just jump from monolith to microservices. They do this. They get stuck in the distributed monolith. That's even harder. You now need to monitor and observe two different operating models at the same time. And I'm pretty sure Jane's team won't double their headcount or their budget. So there are many tools you can use to gather logs and metrics from nodes, and in a few slides' time, we'll go through them. And in the upcoming demo, we will also show you how Jane can use AWS services to perform monitoring and observability to suit both of these operating models. So to begin with, what has had to change in monitoring to suit this new microservices world? Well, first, CPU, disk, and memory is now supplemented with customer experience metrics. These could be metrics such as latency or status codes. And you don't just pick off-the-shelf metrics for this too. If you think about your customers and what they love about your product, you can find a way to map that to an experience metric. Systems which were once pets are now cattle. They're gone quick. There are no agents. There are lots of them, and you need to ensure you collect logs and metrics as soon as they're online. With monoliths, you care about a node's resource consumption, and Jane would investigate potential problems like 90% CPU consumption. But in microservices, if CPU is 90%, but systems are healthy, it doesn't matter. If you unexpectedly scale from 2 to 100 containers in a short time period, that's probably something to investigate. Dashboards. They used to have manual thresholds. Well, you can't create manual thresholds in an environment that changes every day. You need infrastructure as code for simpler deployments, and then you need machine learning tools that can perform anomaly detection and provide automated insights. So what are our objectives? Jane's moving to microservices. We're talking about observability. What does all this actually mean? Well, first up, we care about customer experience. We want to know when customers are satisfied, when they're unhappy, when systems are slow, or just plain not working. And we can't do that with infrastructure metrics alone. We need many different data sources. We need to analyze, report, alarm, and plot trends about it. This leads to operational efficiency. Jane has now been tasked with managing 10 times more infrastructure, which could be configured in multiple development languages. Well, we want to make sure Jane has one way to manage all this stuff, not a different process for every service and every development language. Finally, we want to understand architecture patterns and processes associated with microservices. We also need to understand how we learn in this environment. Microservices is not static. It's an eternally evolving ecosystem, and operational and architecture practices need to evolve just as fast. Now, I've spoken a lot about monitoring and observability, but what's the difference between the two? Well, Amazon CTO Werner Vogels summed up monitoring quite succinctly. Monitoring means that you already know what is important. That's it. Monitoring exists to catch anticipated errors which have known patterns, known thresholds, and known resolution runbooks. These are metrics which have been planned way in advance or identified retrospectively after a system's failure. So whilst monitoring lets you know when something isn't working, observability lets you know why something isn't working. It's the gathering of metrics, traces, and logs from your workload to help you understand its state better. So we're going to go a little deeper into what observability is. As I said, observability is the coming together of metrics, logs, and traces. Now let's see how they apply to 4 common parts of a workload. First, infrastructure. This is nodes such as EC2 instances, containers, container hosts, and operating system metrics. These nodes produce logs and metrics that allow you to gain insight into their health. Then, there are off-the-shelf AWS services like RDS, Dynamo, Elasticache, and Lambda. These are services you can simply consume without provisioning the underlying infrastructure yourself. And services like this come with vended metrics and logs. These are metrics and logs which are enabled out of the box so you can see how they are performing. Then we have application performance, or APM, application performance monitoring. This is the gathering of application metrics and traces. Tracing is a way to get detailed information about what your application is doing. For example, what API endpoints or databases is it calling? You can also check which functions in my code are taking the longest to run. These are usually done with specific agents or by orchestrating your application code with SDKs. Finally, synthetic monitoring. This simulates a user's journey through your stack. This can be for common customer actions like login or payment actions. And performing synthetic queries allows you to run tests that match the user experience and then alarm when things are not quite right. Now, if Jane can gather the metrics, logs, and traces from these 4 areas into one central location in which she can perform analysis, then she has the foundations of an observability platform. Now, here is a common diagram you see a lot at Amazon, the flywheel. And in this example, the flywheel represents the growth and continuous development of observability. The idea here is that the more you perform these steps in your flywheel, the faster your flywheel spins and the better you get at observability. So let's start with detect and investigate. Let's say you have an observability platform configured and an issue comes in. How do you investigate? Well, you could look at customized dashboards, you could perform log analysis, you could also trace calls between APIs and databases. From this analysis, you may identify a remediation action. You can look at patterns of how this happened, and that would lead to root cause analysis, enabling you to react faster, or hopefully even better, preventing an incident from occurring. Based on your remediations, you should then evolve what you're doing. You should be learning from operational events. You should be investing in automation, and you should also modify architecture patterns and processes as necessary. Now, to evolve things, you need more collaboration with other teams, both technology and business orientated. This should lead to new business metrics and greater understanding of business impacts. This should also lead to new application architecture. And performing all these actions in a continuous cycle will lead to faster identification of issues, faster resolutions, faster evolutions, and greater collaboration between your business. It will allow you to gain greater understanding of the applications you are supporting. So what services can Jane use in AWS to perform monitoring and observability? Well, first, there is CloudWatch. There is so much you can do with CloudWatch. You can collect logs and then run queries against those logs. You can collect, view, and analyze metrics. You can check for events and then configure automated responses to those events. You can create dashboards showing logs and metrics. And you can configure alarms when metrics breach thresholds or enable anomaly detection on metrics so you're alerted when metrics deviate from standard patterns. You can also run synthetic queries against your workload to check it is behaving as expected. Then we have X-Ray. X-Ray is a service which you can use to gain insight into your Java, .NET, and Node applications. You can use it to trace requests as they move through your application stack to identify performance bottlenecks. It also provides a dependency map of your applications, so you can build a view of how applications connect to one another. Then we have the AWS distro for OpenTelemetry. This is a vendor-agnostic way to collect metrics, logs, and traces from your application and infrastructure. It is one method to collect all the information you need. It's backed by AWS security, performance, and support. And if you use Splunk, Datadog, CloudWatch, New Relic, X-Ray, it doesn't matter. You orchestrate your code once with OpenTelemetry, and then you choose the backend to send your data to. If Jane's company starts using a new observability provider, no worries. You don't need to re-orchestrate your code. You can simply point it to the new backend. Finally, we have Amazon Managed Service for Grafana and Amazon Managed Service for Prometheus. Prometheus and Grafana are tools you can use to collect and graph metrics and have been very popular with containerized workloads for some time. Traditionally, companies had to host these services themselves. However, these are now managed service offerings in AWS, meaning you can start using the service without provisioning or configuring your own infrastructure. There is more functionality, and lots of it will be shown in the demo, but this gives you an idea of what is possible with these services. In addition to our AWS tools, you can also leverage our partners. The monitoring and observability space is full of tools and partners, so be sure to check them out. Some you may even be using already. Now, I've spoken a lot about the theory of monitoring and observability in AWS, but what does a real-world view of all this look like? Well, for that, let's hand over to our next presenter, Frank, and he can walk us through how Jane supports an e-commerce pet adoption application with a microservices architecture.
Thanks, Stephen. My name is Frank Fan, Solution Architect from AWS. Let me share a story of Jane. Jane recently joined a company that runs a very successful business to help people adopt pets. They just had a marketing campaign to provide big discount to their customers. It's a normal Saturday morning. Jane was waiting for her friends to go to see a movie when the phone rang. Hi, Jane, this is John. John is the head of the technology. We have lots of customers complaining about our website. It took a very long time for them to complete a transaction. We need you to help to fix it urgently. Jane rushed into a cafe and tried to find some document about the application, but the document is out of date. She logged into console and couldn't figure out where to look at because so many applications running in this environment. She decided to ring you as a trusted and experienced colleague to help her out. Luckily, you just learned about observability at AWS from Stephen just now. How would you help Jane? In this demo, I will walk you through the steps. Firstly, you should start with getting an end-to-end view of your application. With service maps, you will be able to visually look at your components of the microservices application, how they talk to each other, and easily pinpoint what issue you need to look into first. Then you use Log Insight which enables you to search and analyze your log data in Amazon CloudWatch logs. And you add a query result in the dashboard to closely monitor it. After that, you dive into metrics, logs, and traces to complete the root cause analysis and figure out remediation plan. Last but not least, you continuously verify your customer experience from end to end. It enables you to discover issues before your customer do. Keep this flow in your mind as you will follow the sequence to find the root cause. Let's look at the website Jane's company provides to their customers. The front end lists all the paths available for adoption. It's a separate application running on EKS, Elastic Kubernetes Service. It has no business logic at all. Every single button on the page is actually from separate microservices. For example, search or this button, take me home. When you click this button, it will invoke another microservice. When payment transaction completed, it will return a status on the page. Adoption complete. This status stored in DynamoDB. Let's jump onto the CloudWatch console, where you should look at first. Metrics, logs. There are so many of them, and it will be very time-consuming to figure out which one caused a problem. Luckily, you just need to click Service Map in Service Lens. It provides an end-to-end view of your application, and it helps you more efficiently to pinpoint performance bottlenecks. To see a service map, you must have installed AWS X-Ray and completed the other Service Lens deployment steps. A service map displays your service endpoints and resources as nodes, and highlights the traffic, latency, and errors for each node and its connections. As customers complained about it takes a very long time to complete a payment transaction, we need to change the display mode. By default, its mode is requests, but now change to latency mode. Now the page refreshed. Each node represents a service in the application. The bigger the node is, the longer time takes to complete the request. The thickness of the connection indicates the time required when the request traverses from one service to another. Select Pay for Adoption Service and click View in Container Insight. You can set up Container Insight on new or existing Amazon EKS or ECS, Elastic Container Service clusters. You use Container Insights to collect, aggregate, and summarize metrics and logs from your containerized applications and microservices. You set up the CloudWatch agent on your Amazon EKS or ECS cluster to send metrics to CloudWatch, and also set up FluentD to send logs to CloudWatch logs. Let's start with front end. It shows up all the metrics. It looks normal, so we can rule it out. Let's look at a different one, which is a Pay for Adoption Service running on ECS. Click Dashboard. It shows more metrics. The memory utilization is fluctuating with a pattern. It indicates something worth your attention. So if you take a close look, so it starts with a low utilization and goes up and goes down and repeat that pattern. It's very interesting. But we want to get more information about what's behind that. You can choose to go to another page, which is View Metrics. It shows more information for you, and you can take other actions. For example, you can set up alarm based on anomaly detection band to notify you when this pattern occurs next time. We just looked at metrics and showed some memory issue, but we are not 100% sure. So what's next? We want to figure out what exactly root cause to cause the end user problem. Let's go back to Container Insight. We need to select the services we care about. So we pick up Pay for Adoption service and click View Logs. CloudWatch Log Insight enables you to search and analyze your log data in Amazon CloudWatch Logs. You can perform queries to help you more efficiently to respond to any operational issues. We put in the log group ECS Pay for Adoption and just copy and paste, pre-configure the script here. It's quite simple. What it does is a search for a keyword, transaction here. We want to find out successful transactions in the log in 5 minutes interval, and we come up with an aggregated number. Let's take a look at what's coming up from the logs. You can see the timestamp and also number of events. Click Visualization to get a chart. It's very meaningful metrics here. You can see the number of events going up and not down, but still remain in a range. Probably end user experience get impacted by underlying resources constraint, but the service is still fulfilling the requests all the time. This is helpful because it tells you how your end user is sending the request and get the request serviced. Click Add Dashboard, and this is a customizable homepage that you can use to monitor your resources in a single view. So you can easily monitor these metrics next time by click Dashboard. You don't need to instrument or maintain separate code to create custom metrics, something like this. You just used the application data in the form of logs to generate metrics. This is super powerful. You just looked into metrics and logs and you wanted to figure out the root cause. We need to go back to Service Map to navigate further. This time, you wanted to know what exactly caused the end user problem. Click Pay for Adoption service and click View Traces. Select Node Status. We can filter the traces which have faults. So they list all the traces we captured. There are many of them. They are doing different kind of things. Let's find out the one which is related to the pay for transaction. We pick up one, and then it will direct us to a next page. Here we go. We got a trace map. It is a visual representation, shows how the requests initially sent by end user and traverse all the microservices. The end user initiated the request, then hit the front end, and then pay for adoption service, and then invoke other Lambda functions. In the end, it will update DynamoDB. Segment timeline is also a very interesting information provided to you. It shows data from all segments in a trace and how long the request was fulfilled in each segment. There is a fault in the pay for adoption segment. Scroll down to the bottom, and under logs, you will find log data across different services captured at the moment this trace was recorded. In this example, you will be able to see logs captured by an ECS service, pay for adoption, and also the logs recorded by the Lambda functions. All that at the same time. You expand this item and find out error, illegal memory allocation. Remember, we found that memory pattern fluctuating earlier. This validated our thought that the end-user problem may relate to memory constraint. What actually happened in this situation, we pre-configured with a limit as a hard limit in the ECS. The resolution is to increase the limit. Are we finished? Not yet. This memory issue contributed to the end-user problem, but there is still another one. Go back to service map and select DynamoDB. Click View Dashboard, and you will see alarms. The problem here is the actual read request is way above the reserved read capacity unit 240. You can choose to increase it or change it to on demand instead. You helped Jane find out the root cause of the problem and fix it. However, it's not done yet. You wanted to proactively assess end-user experience as ongoing operational process. Synthetics can help you monitor web applications using HTTP or HTTPS endpoint. You just need to create a canary here. Let's select one already configured. Click Configuration, and you configure the HTTP endpoint. That's what we are going to test against. And some clicks. Canaries follow the same routes and perform the same actions as customer. So click Screenshots. So system automatically simulates clicks as end user. Click Monitoring. And you can see more information and interesting metrics here. We can pick up one and also add that to the dashboard. You can also add these metrics and configure Amazon Event Bridge, which can notify you when canaries changes status or complete run. So you will find the issue before people call you. We show here that with a few AWS services, you can have a deep understanding of your application behavior and therefore fix the issues quickly. The key takeaway for this demo is to gain insight of your application before diving into metrics and logs. With Service Lens, you saw you are not only able to understand the service interaction data through X-ray traces, but also get one consolidated view about logs from various microservices when the trace was recorded. Let me hand over back to my colleague, Stephen.
Thanks, Frank. So in that demo, we have gained great insight into what tools and services you can use to get started with monitoring and observability on AWS. Now let's recap some of our objectives and see what we have done to help our IT admin Jane in her day-to-day life. With customer experience, we have shown how X-ray can be used to identify slow-running queries. Knowing where our application is performing poorly makes providing a fix simpler and allows us to resolve customer-impacting performance issues faster. With operational efficiency, we have demonstrated how CloudWatch naturally collects logs and metrics. Service Lens and Container Insights also produced out-of-the-box dashboards which you can use to examine workload performance. Finally, with architecture patterns and processes, we showed how AWS services like X-ray, CloudWatch, Service Lens, and Container Insights provide a real-time view of what services are running in Jane's account and how they're communicating. Documentation and architecture diagrams can quickly turn stale, and it's incredibly difficult to maintain this in a microservices model. With AWS, the monitoring and observability platform is your architecture diagram. It shows Jane her application architecture in real time. These benefits addressed here should help Jane keep her customers happy. They should lower the burden of maintaining a microservices architecture And also, they should allow her to continually evolve her practices so that workloads can keep on enhancing. Now, if you like the look of the demo application we used today, then you are free to try it at home anytime you like. Simply go to the link at the top of the screen. If you want to keep up to date with anything to do with monitoring and observability in AWS, then we have the link for you to check out our website. We've put a link on the screen for the AWS distro for OpenTelemetry, which, as I mentioned before, is one mechanism to collect your metrics, logs, and traces. And if you want to get deeper into CloudWatch with things like EKS and Lambda, then please use the link at the bottom for more labs that you can try at home. And if you want to read about many of AWS's published best practices with operations, you can use the bottom link to read about the operational excellence pillar from the AWS well-architected framework. There are loads more ITA talks at the summit too, so please check out the rest of the sessions in this track. Now, this is a great time to learn, but it doesn't need to stop when the summit does. We offer over 45 online digital training courses that are available on demand. You can go deeper with a 3-day instructor-led course called DevOps Engineering on AWS, and you can gain credibility and confidence with 2 related certifications. You can also explore labs, white papers, and other technical resources by downloading the AWS Ramp-Up Guides. For more information, visit aws.training/DevOps. That's all we have for you today. Please use the session survey link to provide your feedback. But from Frank and I, enjoy the summit, and thank you for watching.